This question is all about what kinds of expressions can I compute and what is this null thing that keeps coming up. We're going to take a look at more complex single row expressions, and we're going to take a look at what null means and how to work with null. And so let's take a look again at the data that we have. It is each adventurer, their profession, their species, and what level they are. So you can see the first adventurer is level 5, the last adventurer is level 6. Each monster and how many hit points it's worth and how many experience points it's worth, the date, the adventurer, and which monster they happen to defeat on that date. Now, let's take a look at other expressions that we can perform by querying this data. And we're going to use this data set over and over and over. Of course, we can eyeball the data very quickly. Okay, that's what's in the data, the adventure, the profession, the species, the level, the monster, the HP, the XP. Okay, very good. What if I wanted to identify which adventurers were magic users? Well, I know that I have thieves, mage, clerics, and warriors, and I know that clerics and mages, or just mages, are magic users. Maybe spellcasters would be only mages. Well, this is an expression that I want to compute off of an existing column. And you can think of that something like a case expression in your C or C++, or a match expression in your Python 3.10 and later. This exists in SQL. I can select an expression beyond just a computation, like give me a substring or give me a mathematical computation. I can do case expressions, and they come up quite a bit when I'm performing classifications, very simple classifications. Here I say, when the profession is mage, then you're a magic user, otherwise you're not, and I can identify who my high-level players are and who low-level players are. When the level is greater than 7, then you're high level, otherwise you're not. And you can see here the two different formulations for this case statement. One, which switches on a single value and on a single column or a single expression on a column and the different values you can take, and one that is specified on a bunch of predicates and whether those predicates hold or not. So it's not as limited as, say, your C or C++ case expression. For my particular data here, I don't have null values, but I want to talk about what null is because it's going to affect a couple other complex expressions that we want to compute. Here, I have another data set with some nums, some names, and some flags, and one of these flag values is null. And when I see this printed out here, instead of seeing an ugly NULL, you can see I have a nice Unicode character, but I have a true, a false, and a null value. Well, here's the thing. We've seen true, false, null values before, and we've seen them in Python. In Python, we have these 3 singleton values, true, false, and none. And they largely mean similar to what we use null to represent in SQL. In SQL, we use it to represent not applicable, missing data, not available, not meaningful, something of that form. We use it to represent in this trie-valued logic. It wasn't true and it wasn't false, but it was neither not true nor not false. It was a third category, like missing. Well, this is how we use none in Python. True is, yeah, of course that's true. False, of course it's false. None is, you're asking the wrong question, buddy. And the true, false, and none singleton values are just single objects that exist only once in an entire Python program. So true is equal to true is identical to true, false is equal to and identical to itself, and none is equal to and identical to itself. But in SQL, when we have a null value is not equal to itself. When you say is null equal to null, you get null back. When you say is null not equal to null, you get null back. One of the interesting things is this null is actually kind of similar to a nan. Any computation you perform on this just gets soaked up by that nan, and it gets stuck as a null or it gets stuck as a nan. And you've seen this before in your pure Python or in NumPy or Pandas. If you have a nan value, nan is not equal to itself. It is identical to itself. This is the same nan object. I'm not creating 2 different nan objects. It's the same nan object. It's not equal to anything, not even itself, because the nan in Python and numerical computing represents an error case. It means not a number because you did something wrong here. Well, this is what the null represents in SQL. It means something went wrong here, so it's not fair for me to consider this a true value or a false value. It won't be equal to anything. And a very strange thing is, well, then why is a Python list with a nan value equal to itself, but a NumPy and D array with a nan value not equal to itself? But I'll leave that for you to discover. It's a very interesting answer for why that might be the case. What do we do about nan values, NA values, or the like in Pandas? Well, we don't say, oh, give me all the rows of this series where the value is none or NA, because that's not going to work. I can't filter this. I just get a bunch of NAs back, very similar to how nulls work. I have to use some special syntax. I have to say something like is NA. I'd say give me the rows where this criteria happens to meet, because that equals and not equals really only works with my Boolean types. Very similarly, in SQL, if I want to identify the rows where something happens to be set or not set, well, I can't say where the flag is equal to null or the flag is not equal to null. I have to say where the flag is null or where the flag is not null. And this leads to something that happens very commonly. I want to treat a null value with a particular default. So I want to say if you didn't fill this in or if this is missing as a consequence of some join, I want you to treat it as though it were false. This is what coalesce does. Anytime you're working with null values, think about, well, would it make sense for me to work with this null value? And is it important for me to have identified that this is missing? Or do I want to collapse that to a singular non-null value? Do I want to coalesce it? All coalesce does is it takes a bunch of expressions and it gives you the first value that happens to not be null. And so here, this allows me to set a default. You could think of this as a case statement. This is, false if flag or case flag where null. Actually, no, I'd have to do it with the full expression. I'd say case where flag is null, false, else flag. A little bit shorter with the coalesce. Here, you can see that I have some data that was probably either hand-entered or from some other system, because it's clear that I have a not applicable value, but they didn't write it out as null. They didn't perform the actual transformation, the data cleaning to turn this into a null value. They left it written out as n/a. So here, if I select from this table, I can say select where the name equals n/a. This is probably not something that's worth maintaining in my data store in the long run, because this is going to get really complicated if it's n capital A, or I probably want to convert this to null. But sometimes we just have to deal with data, or sometimes we have a table that needs to reflect what the raw data input looked like before we turn it into some sort of analytical table. In these cases, what I might use is a function called null-if. And null-if you can think of as going in the opposite direction of coalesce. You can say, given a particular column or a particular expression, if it happens to match a certain value, consider it null. And so here, what I'm doing is I'm saying this table might include both these handwritten NA values and properly encoded null values. And as you go through this, if you see an NA value, consider it to be a null value. So what null-if does. So you can see we have these common approaches to both convert away from or to eliminate nulls, but also to convert to and to preserve nulls. Nulls are not something that you want to avoid in your data. They're something that you want to be very careful about how you use to represent something was missing, and you need to be careful about how you operate and manipulate these. So here's what we did. We took a look at what that null means, something very similar to NA in pandas or none in Python. It represents missing data. And we talked about common functions that you might use, coalesce, case, and null-if, to operate on these individual rows and to perform some sort of match statement style, case switch statement style lookup, or to perform conversions to and from nulls in order to either preserve a notion of, oh, this is missing, or to say, you know what, sure, it's missing, but for the purposes of this query, I want a default.